Okay, guys, today we're going to do some more review because we realized that you didn't do multiplication and division very well last class. You saw the struggle. So we're going to go back through, break this down one more time to make sure that you can understand. Some of you guys have a backward packet. Make sure you're starting on this page. Okay, so we're going to start with this very basic question for each of these. If I look at, and here's the whole key on this, guys. First off, pull out your vocab sheet. And who can tell me what inverse means? Your vocab sheet out. Get your vocab sheet out. Look at number 9 and tell me what inverse means. Okay, Sandy?
Inverse operations are pairs of operations that reverse the effects of each other. For example, subtraction and addition are inverse operations. No.
So, pairs of operations that reverse the effect of each other. You guys put your vocab on so you can see this isn't new. We've actually been talking about this for about the last 4 lessons. Guys, this is the basis of everything that we are going to do. The reason we do the inverse operations is they undo themselves. Meaning, I can get my variable by itself on one side of the equation. Well, if I have my variable by itself on one side, whatever's left on the other side is what that variable equals. That's how we solve an equation. And we do it through inverse operations. Okay? So, it's all about balancing. Anything I do to one side, I have to do to the other side in order to get my variable by itself. So it starts by identifying where my variable is. That's why we circle it. And then we draw the line because that scale has to happen on both sides. So as I see my variable, what number is with it? No, x is the variable. What number is with it?
4.
4. The first question you ask yourself, what is the operation between 4 and x?
Multiplication.
Multiplication. If I write them side by side, guys, that is multiplication. Is there anyone who doesn't see that? Okay, to unsolve it or undo it, we have to do the opposite. So what is the opposite of multiplying? Division. So I am going to use division. I'm going to take my variable. I'm going to divide both sides by the number that is with the variable. In this case, it is 4. Does everybody see that? Why do we do that? Because what's 4 divided by 4?
0.
1. What's 1 times any number?
Itself.
Itself. Multiplication identity property of 1. On the other side, so on this side, I take x, 4 divided by 4, and I end up with just x on my scale. On the other side, I take 12 divided by 4, and I end up with 3. So my solution is x equals 3. Okay? So, mathematically, let's just use our box to show what we did. We did 4x equals 12, yes? Please, just do this. I know there's a bunch of you that looked at it and said, this is stupid, Mr. Why I don't need to do this. And then you couldn't do any of the homework because you didn't understand what to do. If you will get used to this process, you will understand what to do. Circle your variable, draw the line. What number is with my variable? The operation is multiplication, so the opposite is divide. So I'm going to divide both sides by 4. Why? Because 4 divided by 4 gives me 1. 1 times x means x is left here. 12 divided by 4 is 3. That is my solution. Is anything in there difficult? There shouldn't be. If you'll just follow the steps, it's actually really easy. If you want to be like Zara and just start substituting numbers in, as the numbers get hard, you're going to be really confused because you don't know what to do. So please, practice while it's easy, guys. Okay, let's look at the next one. Again, we focus in on our variable. What number is with my variable? 3. What is the operation? And that's the key. Division. So right now, my operation between my variable and my number is division. Okay? So what is the inverse of the division? Multiplication. So we're going to have to, and I apologize, I don't know why I didn't give us more room here. That's multiplication. So as I am solving this, here's my variable. I draw my line. The opposite of dividing by 3 is multiplying by 3. So I'm going to multiply both sides by 3. In this case, it becomes 3 over 1. 3 divided by 3, and we cross those out, they become 1. I now have 1 times x. What does 1 times x equal? X. What does 6 times 3 equal? So my solution is x equals 18. Algebraically, again, let's take a look at it. We write it in our space here. X divided by 3 equals 6. Here's my variable. The opposite of dividing by 3 is multiplying by 3. What I do to one side of the equation, I must do to the other. Multiplication. I got to ask you guys, which property is it that says I need to multiply both sides by the same number to keep it equal? No. Which property says I need to multiply both sides by the same number to keep it equal? Close. Which one? I am multiplying.
Property of multiplication and equality.
Multiplication property of equality. Got property. Don't read, listen to the video, you got property. Okay? So multiplying a whole number times a mixed number or a fraction means I put it over 1. And I have 3's on top and bottom, those go away. So x equals 18. There's my solution. Make sense?
Yeah.
Wow, if you actually do what we asked, it makes sense. You would have thought that. Okay, guys, we have 4 down here. These are basically fact families. I'm going to give you guys about 30 seconds. Fill in those fact families. Okay, everyone should have that done by now. 2 times 6 equals 12. So what number do I divide by 2 to get 6? 12. Does that make sense? Inverse operation. 22 divided by 11 is 2. So 11 times 2 is 22. Does that make sense? Guys, that's literally all we're doing in these. We're just reversing the operations so that we can solve the problem. Okay, on this page, we broke it down again, step by step. The process is always going to be the same. So for your variable, draw your line. Find the operation that's happening, put it under being performed. So for the first example, what operation is happening here? Division. So here I'm going to write division. And then we're going to have you write for now, what's my inverse operation of division?
Multiplication.
Multiplication. And then you're actually going to do it. So the opposite of dividing by 8 is multiplying by 8. So I do that on both sides. These go away. They will always go away. Why we do it? How we solve an equation. So I now have my variable left on this side. 3 times 8 is 24. So you guys have 5 more to do. We'll give you about 5 minutes. Go ahead and go. Okay, our next one. I circle my variable, draw my line. What's the operation? Right now it is multiplication.
Oh, guys, we're talking.
So the inverse is division. Meaning I'm going to divide both sides by 7. Those go away. P equals 6. Did it matter that the variable was on this side of my equation? No, that's right. Yeah. Here's my variable. What operation is being performed on the variable? Division. So the inverse is going to be multiplication. Meaning I'm multiplying both sides by 2. Put that one over 1 so that I can do my reductions. R equals 20. That's it. If you reversed it, then R equals 20 would count. count that one.
Oh,
But I like to keep it all in order to help me make sure I keep everything straight. R equals 20 would still be good. Okay, our next one, here's our variable. What operation is being performed? Multiplication. So my inverse operation is division, meaning I'm dividing both sides by 3. Why? So those go away. I have y equals 9. Here's my variable. What's the operation being performed? Division. So the inverse is going to be multiplication. By multiplying both sides by 6. That one goes over 1, so those can go away. M equals 30. Here's my number. What's the operation being performed? Multiplication. So we're going to do the inverse, which is division. So I'm going to divide both sides by 2. Again, let's go away. C equals 12 is my solution. If you will follow the process, everything in this becomes easy. If you continue to try to just substitute as we throw harder numbers at you, you're going to be lost. The only big caveat I will add, let's go to our next page. Here's where we're going to start throwing some extra stuff at you. When I have my variable and the number with it is a fraction, I am still doing the same thing. I'm dividing. The issue is when I divide by fractions, we don't actually divide fractions. Instead, we multiply by the reciprocal. So if there's a fraction involved, your initial step just needs to be multiplied by the reciprocal. And I have to show it on both sides of the equation, guys. Okay? So I've already set number 4 up for you. You should be easily able to solve that one now. We're going to have you do the first 6. We'll give you guys 10 minutes to solve these first 6. We'll go over the first 6 to make sure everyone's catching. If you finish them before your 10 minutes, you are free to go on. Remember, your homework is anything we don't complete today. So the more you can do now, the better you will be served tonight when it comes homework time. So you have 10 minutes. Go ahead, keep going.
All righty, guys, let's look at the first one. 12 equals 6K. What am I doing in that equation? Multiplying. So to solve, I'm going to divide. I know I want K by itself because I want to know what K equals. Yes? So I need to divide by 6 on each side. This crosses the 6's out, makes it 1. And 12 divided by 6 is? 2. Does it matter that I made those 6's one whole? Is that going to change my answer? Does 1 times something change the number? No, it's still itself, right? That's why we can just write K. We don't need to write the one whole because it doesn't change the fact that it's still K. Make sense? All right, 4x equals 32. What am I doing? Not hard, guys. Operation. Multiplying. So to solve, I need to divide. I know I want x by itself because I want to know what x equals. So I'm dividing by 4 on each side. That crosses each other out. 32 divided by 4 is 8. All right, what am I doing on number 3? Multiplying. So I need to do the opposite, which is dividing. I want to know what x equals. So I divide by 2. That crosses them out, leaves just x. 24 divided by 2 is 12. All right, Mr. Moore started this one for us, but let me show you why. When we are dividing, can we divide fractions? No, we keep, change, split. Yes? That is why we are multiplying both sides by 3 halves, because we are multiplying by the reciprocal from the division. Does that make sense? Any questions? All right, so the 3's cross each other out. These 2's cross each other out and leave x. I make the 4 a fraction. 4 times 3 is
12.
12. 1 times 2 is 2. 12 divided by 2 is 6. Number 5. What operation am I doing? Multiplying. So to solve, I need to divide. So I'm dividing 1/2 by 1/2. Can I do that? No. I need to keep, change, flip. So what am I actually going to be doing to both sides? Multiplying by the inverse, which is 2 over 1. So the 2's and the 1's cross each other out and leave just x. 2 times 12. 1 times 1. 24 over 1 equals 24. Any questions about that? That's what it says. Half of 24 is 12. Yes? What's the question?
That's why you make the video. I got it.
All right, number 6. What operation am I doing? Multiplying. I need to know what D equals, so I want it by itself. So what do we need to do to those mixed numbers? Improper fractions. 2 times 1 is? Plus 1 is? So that turns into 3 halves. 2 times 4 is? Plus 1 is? And that turns into 9 halves. So if I'm multiplying, how am I going to solve? Divide. I'm going to divide both sides by 3 halves. But can I divide fractions? No. What do I need to do? Keep, change, flip, multiply by the reciprocal each time. The 2's cross each other out, the 3's cross each other out, and leave just D on that side. And on this side, what is 9 times 2? 18. 2 times 3? 18 divided by 6 is 3. Any questions about those? All right, you have the bottom part of the page, which is the last 6, and number 13, where you're going to work out each problem to see if x is 6 and circle the ones that work. Any questions? All right, go for it. Make sure you are showing your work.
Okay, I'm gonna give you 10 minutes to do this. So this should just be checking. That's why I'm gonna go through this in about 2 minutes. So the opposite of dividing by 5, multiplying by 5 is going away. How was that, right? F equals 50. The opposite of dividing by 3 is by 4 is multiplying by 4. Those go away. So I have G equals 24. The opposite of dividing by 8 is multiplying by 8. These go away. So X equals 848. This one, the opposite of dividing by 7 and 2 is multiplying by 7 and 2/10. These go away. Times 7 and 2/10 is going to give me T equals 6, 21.6. The opposite of multiplying by 1 5/10 is dividing by 1 5/10. These go away. V equals. Now this one gets a little more complex. 1 5/10. You can't divide with the divisor as a decimal point. You do that one thing, and you move this one once. Keep them equal. 50 goes into 96 times. Subtract 90. V equals 6. Here's our variable. The opposite of multiplying by 2.5 is dividing by 2.5. Issue. I have a divisor with a decimal, meaning my decimal needs to move once, so I need to move it once on the inside as well. 25 will go into 1 or 10 goes into 104 times. I still have another place I need to account for. So even though it's a 0, I need to have that there. So G equals 40. Any questions on those 6? Guys, you see how fast this goes once you understand and do the process? Is anything up there difficult to do? So just do it. Literally, if you'll just do it, this is going to become second nature for you. I promise you. This is as easy as we can make it. So these four, we just need to check real quick. 4x equals 24. Here's my variable, so I'm dividing by 4. X equals 6, that one worked. X over 2 equals 3. Here's my variable. Now, so dividing by 2 is multiplying by 2. These go away. X equals 6, that one worked. 14 equals 7r. Here's my variable. I'm dividing both sides by 7. Those go away. R equals 2. That one didn't work. Our last one, x over 6 equals 36. The opposite of dividing by 6 is multiplying by 6. These go away. X equals 36. 18 turns 16, so that one didn't work. So why don't you work for A and B? Any questions on that? Are you guys starting to feel the flow on these? Okay, so we'll give you a big chunk. We're going to have you do the whole page now, including one at the bottom. You guys have about, what do we have left? 17 minutes left in class. We'll give you guys 12 minutes to do this page. Okay, guys, we gave you 12 minutes. So you should all have this done. That means I have 4 minutes to do them all. Give you guys the answers, if we can do it.
You just wanted to see if you could do them in 4 minutes.
There you go. Okay, divide by 5. Goes away. C equals 4. Multiply by 15. These go away. X equals 30. Divide by 12. These go away. F equals 2. Excuse me. Multiply by 2. Y equals 80. Multiply by 301. Goes away. X equals 24. Divide by 9. Goes away. G equals 4. Okay, this one we do need to slam dunk. So that gives us 7 halves. So that I can reverse that. 2 sevenths. 2 sevenths. These all go away. I have D equals. I've got 1 reduction. 5 over 21. The opposite of multiplying by 7, dividing by 7. Those go away. That's going to go 13 times. Opposite of dividing, multiplying by 4 is dividing by 4. Those go away. That's 12. Opposite of dividing by 3.5 is multiplying by 3.5. These go away. T equals 12, 14. Opposite of dividing by, multiplying by 1.5 is dividing by 1.5. These go away. Y equals 2. Again, we're just checking answers. You should have that written somewhere. Opposite is multiplying by 8. These go away. H equals 48, 44. And our last part, we're just checking which ones have a solution of 9. 3y equals 27. Divide by 3. These go away. Y equals 9. So A worked. Y over 3 equals 3. Multiply by 3. Excuse me, they go away. Y equals 9. That one worked. 36 equals 4y. There's my variable. So now dividing by 4, these go away. Y equals 9. That one also worked. And y over 2 equals 18. Here's my variable. So I'm now multiplying by 2. Y equals 36. That one didn't work. So 3 of the 4 worked. And we saw 2 minutes ago. Yes. Hold on. Quiet, please. So your homework is whatever we have not yet finished. So you shouldn't have a whole lot of homework left. I will tell you, pay attention to the problems, but make sure you show your work. Remember, when we're grading homework, we're looking at your work, not your answers, correct? When I do a paper, I do an answer, going to cut for that. Even if it's the same, do the same. You still need to show. Okay, good luck, guys.